Whether you're just starting chemistry or prepping for an exam, there's one skill you absolutely have to master: dimensional analysis and metric conversions. In today's video, we're going to walk through some of the most important and commonly tested conversion problems you'll see in chemistry, physics, and even real life. I've broken the problems into clear categories, and for each one, I'll show you how to set it up, cancel the units, do the math, and check your answer with the correct sig figs. So grab your calculator, pause when you need to, and let's really understand how dimensional analysis works from the ground up. Let's get started. For metric prefix conversions and dimensional analysis problems, the best way to problem solve is to create a unit map, list all the conversion factors needed to go between the units, and then set up the units so they cancel based on the given or starting value and unit. The first category will have single-step prefix conversions to base unit conversions. These are the simplest problems where you start with a prefix unit and convert directly to the base unit, and the base unit can be meters, grams, liters, or seconds. For example, we could convert from microseconds, the prefix unit, to seconds, the base unit, or milligrams, the prefix unit, to grams, the base unit. For this question, we are converting kilometers to meters. Since we are starting with the prefix unit kilometers and converting to the base unit meters, this will be a single conversion. On our unit map, we write kilometers to meters, and the conversion factor is 1,000 meters per 1 kilometer. Our given value is 5.2 kilometers, so we write it as 5.2 kilometers over 1 to be able to have a top and bottom to cancel out units. In the next fraction, we place 1 kilometer on the bottom and 1,000 meters on the top. The kilometers cancel out and we are left with meters. We have the unit we need for the final answer. Multiplying 5.2 times 1,000 gives 5,200 meters, or in scientific notation, 5.2 times 10 to the third meters. For this question, we are converting 1,500,000 microseconds to seconds. We are starting with microseconds, which is a prefix unit, and we are converting to seconds, which is the base unit. This will be one conversion from microseconds to seconds. So on our unit map, we write microseconds to seconds, and the conversion factor will be 1 second for every 1 times 10 to the 6 microseconds. We start with 1,500,000 microseconds over 1. In the next fraction, we put 1 times 10 to the 6 microseconds on the bottom and 1 second on the top. The microseconds cancel out, and we have our end unit seconds that we need for the final answer. Dividing the values, we get 1.5 seconds. If you like the move the decimal method, micro, or 10 to negative 6, means we move the decimal 6 places to the left. It will give you the same answer. For this question, we are converting 450 milligrams to grams. We are starting with milligrams, which is a prefix unit, and converting to grams, which is the base unit. This will be one conversion from milligrams to grams. So on our unit map, we write milligrams to grams, and the conversion factor will be 1 gram for every 1,000 milligrams. We start with 450 milligrams over 1. In the next fraction, we put 1,000 milligrams on the bottom and 1 gram on the top. The milligrams cancel out, and we are left with grams, the end unit that we need for the answer. Dividing 450 by 1,000 gives 0.450 grams. Here's a quick confidence boost checklist that you can keep in the corner of your notes while you are working on problems. We're always going to start with the given number over 1. Build a unit map you can trace with the correct conversion factors. Put the next unit where it cancels the previous one. Multiply all top values and divide by the bottom values. And round at the end. And don't forget to label your final unit. Now it's your turn. Pause the video and try this question. Convert 0.085 kilometers to millimeters using dimensional analysis. List your conversion factors, write your unit map, and drop your final answer in the comments with correct sig figs. For the next category, we have two-step prefix to prefix conversions. These require going from one prefix unit to another by passing through the base unit. For example, if I wanted to convert between kilometers and centimeters, I would have to use meters, the base unit in between. And for gigabytes and kilobytes, I would need the base unit bytes to convert in between. For this question, we have convert 2.5 kilometers to centimeters. Here we are converting between two prefix units, kilometers and centimeters, so we will first go to the base unit meters and then to centimeters. Our unit map is kilometers to meters to centimeters. The first conversion is 1,000 meters for every 1 kilometer, and the second is 100 centimeters for every 1 meter. We start with 2.5 kilometers over 1. In the next fraction, we put 1 kilometer on the bottom and 1,000 meters on the top. In the next fraction, we put 1 meter on the bottom and 100 centimeters on the top. The kilometers cancel out and the meters cancel out, so we are left with centimeters, the unit we need for our final answer. Multiplying and dividing all values, we get 2.5 times 10 to the 5th centimeters. For this question, we have convert 4.1 gigabytes to kilobytes. We are converting between two prefix units that have the same base unit. Gigabytes and kilobytes both have the same base unit, bytes. Our unit map is gigabytes to bytes to kilobytes. The conversion factors are 1 gigabyte is 1 times 10 to the 9th bytes, and 1 kilobyte is 1,000 bytes. We start with 4.1 gigabytes over 1, and in the next fraction we put 1 gigabyte on the bottom and 1 times 10 to the 9th bytes on the top. In the next fraction we put 1,000 bytes on the bottom and 1 kilobyte on the top. The gigabytes cancel out and the bytes cancel out. We are left with kilobytes, the unit we need for our final answer. Multiplying and dividing all values, we get 4.1 times 10 to the 6 kilobytes. For this question, we have 0.0045 kilograms to milligrams. We are going from kilograms to milligrams, so we will go to the base unit grams. Our unit map is kilograms to milligrams. 1 kilogram is 1,000 grams, and 1 gram is 1,000 milligrams. We start with 0.0045 kilograms over 1. In the next fraction, we put 1 kilogram on the bottom and 1,000 grams on the top. In the next fraction, we put 1 gram on the bottom and 1,000 milligrams on the top. The kilograms cancel out and the grams cancel out. We are left with milligrams, the unit we need for our final answer. Multiplying and dividing all values, we get 4,500 milligrams. In the next question, we have convert 0.075 kiloliters to microliters. We are converting from kiloliters to microliters, so we will go to the base unit liters. Our unit map is kiloliters to microliters. 1 kiloliter is 1,000 liters, and 1 liter is 1 times 10 to the 6 microliters. We start with 0.075 kiloliters over 1. In the next fraction, we put 1 kiloliter on the bottom and 1,000 liters on the top. In the next fraction, we put 1 liter on the bottom and 1 times 10 to the 6 microliters on the top. The kiloliters cancel out and the liters cancel out. We are left with microliters, the unit needed for the final answer. Multiplying and dividing all values, we get 7.5 times 10 to the 7th microliters. For this question, we have a shipping company accepts a package that weighs 0.0023 megagrams. How many milligrams does the package weigh? We are starting with megagrams and converting to milligrams, so we will go through the base unit grams. Our unit map is megagrams to milligrams. 1 megagram is 1 times 10 to the 6 grams, and 1 gram is 1,000 milligrams. We start with 0.0023 megagrams over 1. In the next fraction, we put 1 megagram on the bottom and 1 times 10 to the 6 grams on the top. In the second fraction, we put 1 gram on the bottom and 1,000 milligrams on the top. The megagrams cancel out and the grams cancel out. We are left with milligrams, the unit needed for the final answer. Multiplying and dividing all values, we get 2.3 times 10 to the 6 milligrams. In the next category, we have mixed unit conversions with time or distance rates. These involve converting compound units like meters per second or millimeters per second, where you change both the numerator and denominator units. For example, kilometers per hour could be changed to meters per second, or kilometers per hour could be changed to millimeters per second. For this question, we have a car travels at 90 kilometers per hour. What is the speed in meters per second? We are starting with kilometers per hour and converting to meters per second. For our conversions, we are now working with two separate unit maps to convert from kilometers to meters and hours to seconds. The problem solving will be the same. Canceling out the bottom units will look a little different. Our unit maps will be kilometers to meters and hours to seconds. The first conversion is 1,000 meters for every 1 kilometer, and the second is 3,600 seconds for every 1 hour. We write 90 kilometers per hour as 90 kilometers over 1 hour, and we could convert to either meters or seconds first, and both would give us the same answer. In the first fraction, we put 1 kilometer on the bottom and 1,000 meters on the top. In the next fraction, we put 1 hour on the top and 3,600 seconds on the bottom. The kilometers cancel out and the hours cancel out, leaving us with meters per second, the units needed for the answer. Multiplying and dividing all values, we get 25.0 meters per second. In this question, we have a car is traveling at a speed of 108 kilometers per hour. What is the speed in millimeters per second? We are starting with kilometers per hour and converting to millimeters per second. Our unit map is kilometers to meters to millimeters for the distance, and hours to seconds for time. 1 kilometer is 1,000 meters, 1 meter is 1,000 millimeters, and 1 hour is 3,600 seconds. We write 108 kilometers per hour as 108 kilometers over 1 hour. In the next fraction, we put 1 kilometer on the bottom and 1,000 meters on the top. In the next fraction, we put 1 meter on the bottom and 1,000 millimeters on the top. In the next fraction, we put 1 hour on the top and 3,600 seconds on the bottom. The kilometers cancel out, the meters cancel out, the hours cancel out, and we are left with millimeters per second, the units needed for the answer. Multiplying and dividing all values, we get 3.00 times 10 to the 4th millimeters per second. For this question, we have a factory produces 1.8 kilometers of copper wire per hour. How many centimeters of wire are produced in 7.5 minutes? In the question, we are given a conversion factor, 1.8 kilometers per hour. It is easiest to start with single units if we can, so we will start with 7.5 minutes and convert to centimeters. The given conversion has hours as a unit, so we can convert minutes to hours to be able to convert to kilometers with the given conversion. Kilometers to centimeters will be a prefix to prefix conversion, or we can convert from the prefix to base unit to prefix. There are 60 minutes in 1 hour, 1.8 kilometers in 1 hour, 1,000 meters in 1 kilometer, and 100 centimeters in 1 meter. We start with 7.5 minutes over 1. In the next fraction, we put 60 minutes on the bottom and 1 hour on the top. In the next fraction, we put 1 hour on the bottom and 1.8 kilometers on the top. In the next fraction, we put 1 kilometer on the bottom and 1,000 meters on the top. In the next fraction, we put 1 meter on the bottom and 100 centimeters on the top. The minutes cancel out, hours cancel out, kilometers cancel out, and meters cancel out. Multiplying and dividing all values, we get 2.25 times 10 to the 4 centimeters with the correct units that we need at the end. In the next category, we have cubic, volume, and density unit conversions. These will be volume conversions involving cubic units, liters, and milliliters. For example, we could convert from millimeters cubed to liters, we just have to remember that there's 1 cubic centimeter in every 1 milliliter. Or we could convert between cubic centimeters and grams from a density problem, because for density units, it's combining grams and cubic centimeters together as a conversion factor, grams per cubic centimeter. For this question, we have a cube has a volume of 1.5 times 10 to the 6 cubic millimeters. Convert this to liters. We are starting with cubic millimeters and converting to liters. When converting between cubic units and milliliters or liters, we can use the conversion 1 cubic centimeter for every 1 milliliter to connect the two together. We are starting with cubic millimeters, but we need cubic centimeters for our new conversion. These are two prefix units, so we will use cubic meters in between to convert. The unit map will be cubic millimeters to cubic meters to cubic centimeters. Even though cubic will be a new type of conversion, the only difference will be cubing the conversion factors from what we know they are now as single units. From cubic centimeters, we can convert to milliliters and then liters. There are 1,000 millimeters in 1 meter, and we will cube both top and bottom for the new conversion. There are 100 centimeters in 1 meter, and we will cube both top and bottom for the new conversion. There is 1 cubic centimeter for every 1 milliliter, and 1,000 milliliters per 1 liter. In the conversion to cancel out units, you can write 1,000 cubed and 100 cubed, or you can cube them beforehand. We start with 1.5 times 10 to the 6 cubic millimeters over 1. In the next fraction, we put 1,000 cubed millimeters cubed on the bottom and 1 cubic meter on the top. In the next fraction, we put 1 cubic meter on the bottom and 100 cubed centimeters cubed on the top. In the third fraction, we put 1 cubic centimeter on the bottom and 1 milliliter on the top. In the next fraction, we put 1,000 milliliters on the bottom and 1 liter on the top. Cubic millimeters cancel out, cubic meters cancel out, cubic centimeters cancel out, milliliters cancel out, and we are left with the unit needed for the answer, liters. Multiplying and dividing all values, we get 1.5 liters. When a length unit is cubed, the conversion factor is also cubed. That's why 10 millimeters per 1 centimeter becomes 1,000 millimeters cubed per 1 centimeter cubed. For the next question, we have a lab pipette dispenses 25.0 microliters of solution per drop. How many milliliters are in 120 drops? In this question, we are given a conversion factor, 25 microliters for every 1 drop. Starting with 120 drops, we can use the conversion factor given to convert to microliters, and then to get to milliliters, we will convert to the base unit liters and then milliliters. Our unit map is drops to microliters to liters to milliliters. The conversion factors are 25 microliters for every 1 drop, 1 times 10 to the 6 microliters for 1 liter, and 1,000 milliliters for 1 liter. We write 120 drops over 1. In the next fraction, 1 drop will be on the bottom and 25 microliters on the top. In the next fraction, 1 times 10 to the 6 microliters will be on the bottom and 1 liter on the top. In the next fraction, 1 liter will be on the bottom and 1,000 milliliters on the top. Drops cancel out, microliters cancel out, liters cancel out, leaving us with milliliters, the unit needed for the final answer. Multiplying and dividing all values, we get 3.0 milliliters. For this question, we have a small jewelry box has dimensions 5 centimeters by 3 centimeters by 2 centimeters. It is made of silver, which has a density of 10.5 grams per cubic centimeter. What is the mass of the jewelry box in grams? In the question, we are given a conversion factor, 10.5 grams per cubic centimeter. To be able to use those cubic centimeters to cancel out, we have to use the box dimensions to find volume. Volume equals length times width times height, and if we have centimeters for each of these dimensions, multiplying all values together will give us cubic centimeters because we are multiplying centimeters 3 times. 2 times 3 times 5 will be 30 cubic centimeters. And we can now convert from cubic centimeters to grams using 10.5 grams per cubic centimeter. We write 30 cubic centimeters over 1. In the next fraction, 1 cubic centimeter will be on the bottom, and 10.5 grams will be on the top. The cubic centimeters cancel out, and we are left with grams. Multiplying the values together, we get 315 grams or 320 grams with significant figures. In the last category, we have area and surface conversions. These are conversions involving squared units. For example, I could convert from miles squared to centimeters squared by just using the conversion factors that I know I could use between miles and centimeters, but then squaring those values. For this question, we have a rectangular garden plot measures 2.5 meters by 3.2 meters. A fertilizer bag covers 2,000 square centimeters per gram. How many grams of fertilizer are needed to fully cover the garden? In the question, we are given a conversion factor, 2,000 square centimeters per 1 gram. If we find the area, we can have square units, but the dimensions are in meters right now. We can convert the meters to centimeters for both dimensions first, then find the area in square centimeters, and then convert from square centimeters to grams with the conversion factor given. We will write 2.5 meters over 1 and 3.2 meters over 1. For both conversions, we put 1 meter on the bottom and 100 centimeters on the top. The meters cancel out, and we are left with centimeters for both. Multiplying all values, we get 250 centimeters and 320 centimeters. We can now find the area with the equation area equals length times width. 250 times 320 will be 8.0 times 10 to the 4th square centimeters. We now have square centimeters that we can use to convert to grams with a conversion factor 2,000 square centimeters for every 1 gram. We start with 8.0 times 10 to the 4th square centimeters over 1. In the next fraction, 2,000 square centimeters will be on the bottom and 1 gram will be on the top. Square centimeters cancel out, and we are left with grams. Dividing the values, we get 40 with a dot grams for significant figures. For this question, we have a satellite captures an image covering an area of 2.7 square miles. Convert this to square centimeters. We are starting with square miles and converting to square centimeters. Our path will be miles to meters to centimeters. Then square the factor because we are working with area that has squared units. 1 mile is 1609.34 meters, and 1 meter is 100 centimeters. We square all of these conversions, the units and the values. We start with 2.7 square miles over 1. In the next fraction, we'll have 1 square mile on the bottom and 1609.34 squared meters squared on the top. In the next fraction, we'll have 1 meter squared on the bottom and 100 squared centimeters squared on the top. Square miles cancel out and square meters cancel out, and we are left with square centimeters. Multiplying all values, we get 7.0 times 10 to the 10th square centimeters.